Hi there, it's Mr. Graham, and in this short video we'll be looking at how to interpret tables. Now, interpreting tables is one of many skills assessed under being able to handle data or data handling under the maths curriculum. Now, on the screen at the moment we have a table, and the first thing that's very important to do with any sort of information, any sort of table, is to read all the headings and the columns and rows, and to read the title and the explanation of what the table is actually showing. What sort of information is the table displaying? So at the top, I'm going to simply read what's on the screen. This table shows the planets in our solar system in order of distance from the sun. Now, some of you may well be aware of the planets in our solar system, and some of you may even know a mnemonic to help you remember the order that they're in from the sun outwards. And this table is displaying different sorts of information about the planets. So the first column, as we can see on the left hand side, is the name of the planet, and the green arrow is just showing you there the name of the planet. And you can see listed down there we've got Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus and Neptune. To the right, the column is displaying information about the number of moons that the planet has. So how many moons do each of those planets have? To the right again is the length of 1 year on each of those planets. How long in Earth days, Earth years, is 1 year on each of these planets? To the right again, how long is a day on each of these planets? And again, that's denoted in Earth hours and days. How long is a day on each of these planets? To the right again, what is the diameter of the planet in miles? Now you'll see the diameter is accompanied by a little asterisk, and that means that there is an explanatory note. There's extra information to explain what that word diameter means. And if we look at the bottom where the green arrow is showing you now, the extra information is available there. The diameter of a planet is a straight line from one side to the opposite side, passing through the center of a planet. So I suppose in very simple terms, how wide is the planet, if you like? To the right, we've got two columns, all to do with temperature. The first column is the maximum temperature on that planet, and then to the right, the final column is the minimum temperature of that planet. Now you're going to receive, with any sort of data handling question, you're going to receive a variety of different question styles. The most simple question style you'll be asked to answer is simple retrieval questions. Let's look at a couple of examples of those. So if I was to ask, for example, how many moons are there on Mars, or how many moons does Mars have, rather, would be a better way to say that. So we'd have to first of all find the planet Mars, the green arrow showing you there. We then have to scroll across from Mars and find, as you can see, the number of moons there Mars has too. So that was simple, straightforward retrieval. If we're going to stick with Mars, how long is a year on Mars? So again, find Mars, scroll across till you find the year length. How long is a year on Mars? And there you can see it is 687 days. Moving further across, how long is a day on Mars? You can see just to the right, it is 24.6 hours long. 24.6 hours long, just slightly longer than a day on Earth. How wide? What is the diameter of Mars in miles? And again to the right, you can see 4,222 miles, as shown by the green arrow. The maximum temperature on Mars is 20 degrees, not that warm. And the minimum temperature on Mars is a minus 120 degrees centigrade, which is very, very cold indeed, much colder than anything we would experience on Earth. So that was one example of a very simple retrieval task where you were asked to recall, asked to find information about one of the planets on this particular table. However, questions will come in all sorts of shapes and sizes. So let's look at some of the different questions that you might be asked. So for example, if we were asked to find the planets which are moonless, name the planets which are moonless. In other words, the planets which have no moons. We need first of all to make sure we are looking at the number of moons column. There we are. And we're looking for zeros here. So we can see that 0 moons, Mercury, 0 moons, Venus, and you'll see that all the other planets have at least 1 moon. So there are 2 moonless planets, namely Mercury and Venus. Thinking of another question, which will test the same sort of skills. Which planet is furthest from the sun? Which planet is furthest from the sun? Now when we look at the columns here, we've got the planets, the number of moons, the year length, the day length, the diameter, and the temperature maximum and minimum. There are no columns there that actually tell us how far the planets are from the sun. And this is where reading all the information in and around the table are crucial. You might recall I read a sentence before we looked at the table. The sentence at the top. This table shows the planets in our solar system in order of distance from the sun. In other words, the planets are already in order, from closest to the sun to furthest away from the sun. So which planet is furthest from the sun? It must be the one at the bottom here, Neptune. Neptune is furthest from the sun because the table shows the planets in order. On the other side of that coin, which planet is closest to the sun? And the planet closest to the sun must be the one at the top, Mercury, because it is at the top and the planets are put in order from the distance from the sun. So there's another example of having to read information not only from in the table, for information in and around the table as well. Okay, which planet then is the coldest? Which planet is the coldest? So because we're dealing with coldness, because we're dealing with temperature here, I know that we need to be looking at the temperature column at the end. Now coldest, are we needing to look at the maximum temperature or the minimum temperature? And because we're dealing with coldness, it's the minimum temperature. So we're looking for the coldest planet. We're looking for the planet with the smallest number. And because we've got positive figures and because we've got negative figures, that makes it a little bit more difficult. And when we're looking at negative numbers, then the larger the number, the colder the temperature. So you can see at the top we've got minus 184 degrees, that's very cold. We've got 464 degrees, that's very hot indeed. Minus 89, minus 120, minus 110, minus 140, minus 197, minus 204 degrees Celsius. So the planet with the coldest temperature, the coldest planet, would be the minus 204 degrees, which is Neptune, because minus 204 is furthest away from 0. It's the coldest temperature, it's the smallest value in that column. Now, if we think about which planet is the hottest, we're now looking at the maximum temperature, the biggest number, and we're looking for the biggest positive value. You can see that we've got 430 degrees, 464, 57, 20 degrees, minus 110, minus 140, minus 197 minus 204. So we're looking for the biggest positive value, and the largest number there, the biggest value from a positive number is the 464. So the hottest planet is actually Venus. So despite being further away from the sun, Venus is the warmest planet. Moving on to yet another type of question, which is asking to use approximation and rounding. We have a question like this. Which two planets have a diameter that is approximately 4 times that of Earth? Which two planets have a diameter that is approximately 4 times that of Earth? So here we are, we've got the diameter. We need to find Earth first of all, and Earth has a diameter of 7,926 miles. Now, using our rounding skills, 7,926 is very close to 8,000 miles. And we're looking for two planets that are 4 times the size, or to be more precise, have a diameter 4 times the size of Earth. So we're looking for 4 times 8,000. Well, 4 eighths are 32. So 4 multiplied by 8,000 is 32,000. We are looking for two planets with approximately, that word is important, approximately 32,000 diameter miles. So looking down, we've got 3,000, 7,000, 4,000, 88,000, 34,000, 32,000 and 30,000. So the two which are approximately 4 times the size of Earth's diameter would be Uranus at 32,600 miles and Neptune at 30,200 miles. How many planets have a shorter year than Earth? How many planets have a shorter year than Earth? Now, first thing to note is how many. Now, if the question is asking how many, then the answer that is being looked for is a number. We don't need to know the name or the names of the planets, just how many planets have a shorter year than Earth. So it's year length we're looking at. And we'll notice that Earth has 365 days in 1 year. So how many planets have a year that is shorter than 365 days? Well, if we look at each planet in turn, Mercury, 88 days. That is much shorter than Earth, so that's one planet. Venus, 225 days. Again, that is shorter than Earth. 2 planets. Mars, that's more than Earth. Jupiter, Saturn, Uranus, and Neptune are much, much longer than Earth. So the answer, how many planets have a year that's shorter than Earth, is just the 2. And the answer is 2. Those planets are Mercury and Venus, but the question was asking how many planets. So the answer is just 2. How many planets have a shorter day than Earth? How many planets have a shorter day than Earth? Now again, how many? So the answer we're looking for is a numerical value, a number. How many planets have a shorter day than Earth? So let's find the day length for Earth. And we'll see that it's 24 hours. So we're looking for values less than 24 hours. 59 days, no good. 243 days, no good. 24.6 hours, no good, it's more. 9.8 hours, there's 1. 10.2 hours. There's 2. 17.9 hours. There's 3. 19.1 hours. There are 4. There are 4 planets with a shorter day than Earth. Those planets are Jupiter, Saturn, Uranus, and Neptune. But we don't need the names of the planets. The question was asking how many planets. So the answer is just 4. Now I'm going to leave you with a number of questions that you can have a go at answering for yourself. I'm going to leave you with a number that you can have a go answering for yourself. They are questions that might involve retrieval of information and then a calculation or two. A calculation and 2. So challenge number 1 then. Challenge number 1. Can you find the total number of moons in our solar system? So think about where you would look to find the total number of moons. Where's the information held for the number of moons? And how would you find the total number of moons? Think about what that word total means. Pause the video, see if you can have a go to find the total number of moons in our solar system. 2 final questions I'll leave you with then, have a little bit of fun with. Can you list the planets in order of size, starting with the smallest first? Can you list the planets in order of size, starting with the smallest first? Think about which column you would need to look at to find the size of the planet, the size. Pause the video if you'd like to have a go. And finally, final challenge then, challenge number 3. Can you list the planets in order of minimum temperature, starting with the lowest first? Can you list the planets in order of the minimum temperature, starting with the lowest first? Think about where you'll find the information on the table about the minimum temperature for each planet, and think about the skills you'll need to utilize to put them into order, starting with the lowest first. The lowest first. Well, I hope this little tour of how to interpret tables was interesting and a little bit educational for you, obviously, as well. Hopefully you'll feel a little bit more confident than you were at the beginning. Like anything else, it requires a little bit of patience. It requires systematic thought, finding a system that works for you. It does require quite a lot of evaluation and interpretation of material and of information. You've got to look at those column headings very, very carefully indeed. But like anything else, practice makes perfect. So feel free to obviously stop and go back and re-watch the video. In the meantime, thank you very much for watching. Take care.